Well, welcome back, Reg audience. Today we're going into the compute era where no Regcast has gone before. So we're looking at what your data center is going to look like in the next 25 years. So that's quite a long time. I mean, you might not still be working in it in the next 25 years, but you want to leave it in a good state for the next person who is. And so we're looking at some long-term plans, how you get to the long term, what that's going to mean, how the way that we use the data center is going to change, and a lot of stuff like that. There's going to be quite a lot of techie information. So who's going to be doing the techie informationing? Let me tell you about it. So first of all, who's in charge of the message here? So it's HP has said that they've been to find this computer here. And normally we don't say it's, you know, it's one vendor or anything like that. But this is HP's particular vision. But we're not just leaving it to HP. Because joining us today from Intel, we have Malcolm. Malcolm, welcome to the studio. It's your first time here.
It is indeed.
It's nice, isn't it?
Very nice, yeah. Lovely place to be.
That's lovely. Yeah, we'll see how you think about that in the next hour. And what stake is, what do you do at Intel, first of all? That's the bit.
Sure, yeah. So my day job at Intel right now is enterprise technology specialist. So I work with customers around the UK, advising on technology directions, everything from the data center through the workplace.
So how does Intel get involved in this? Do you end up telling people about the data center in 25 years?
Oh, we do, for sure, yes. I guess most people watching probably have an image of Intel as a vendor of some of these sort of base level building blocks, the CPUs and so on.
We're aware of,
I'm sure people are aware of that. However, I would probably say we have three hats that we wear in this. We're a big driver of a number of the new standards that are coming out and enabling a whole bunch of the ecosystem to sort of mass around those standards. And it's probably worth saying too that Intel, like HP, I think, is a big consumer of the technology. So our in-house IT department are at some of the forefronts of actually implementing some of these new directions for the data center. So we have kind of views and parts to play in all of those areas.
Good, we'll find out what these views are in a minute. Martin, welcome back.
Hi.
You were here before, weren't you?
I was.
Now, remind people what you do at HP.
Okay, so I am the Converged Infrastructure Marketing Program Manager for European, Middle East and Africa, and been running that program since 2009.
So yes, now we did something about converged infrastructure a few months ago, and this sort of follows on from it and builds on it, doesn't it?
Yeah.
It's a big thing for HP, is it?
Yeah, absolutely. I mean, I think, like I say, we introduced Converged Infrastructure 2009. If I go back before that, 2006, we had Blade servers. I mean, if you like my credentials in this, I've been working for the company for 35 years. I've worked in servers since the day I began. Everything from OpenVMS systems, Unix systems, x86 systems, non-stop systems. But the future is out beyond all of this stuff, and so my stake in this is to try and explain what our vision is.
Okay, and also, I said we got three people in the studio today. It's
very cosy, actually.
Yeah, I prefer I prefer a little bit of distance. Dale, this is something you're interested in. This actually, this is one of your interests, isn't it?
Yeah, it is. As you know, we do a lot of polling of the reg readers.
Yeah.
We do a lot of sort of interactive stuff with the reg readers, and you know, there's a group of reg readers that are actually, you know, really quite into looking ahead, and they give us all kinds of feedback and anecdotes about the way they see things going, and war stories and so on. So this is actually quite a hot topic.
Trouble is, a lot of hype about these things sometimes, isn't there?
I think that's part of the problem, and you know, one of the things we'll be doing hopefully is actually punching through some of the words and the language that's used, and actually getting to some of the principles and specifics and concepts, because I think sometimes words get in the way as marketing people try and kind of use the same words for different things, and they recycle words and so on, and so you know, hopefully
We've got them locked in a box outside. Okay, so thank you very much, guys. Now remember, because this is your Regcast, if there's some questions that you've got, if we're explaining things, we don't make it clear, then drop us a line. It comes through to me on the little tablet here, and I ask the guys to explain it again. If you've got an opinion about it, this is the sort of thing that I've been looking down at the reg notice boards and things, and this is a thing that quite a few people do have an opinion about. If you've got an opinion about it, let us know what that is and put it to the guys. And if there's anything that we're just not talking about and you want to know about it, ask us. Don't complain to people afterwards. Ask us during a Regcast and we'll answer it for you. So let's get on with it. I suppose the first thing that we ought to talk about, guys, is if we're talking about this new era of compute, the compute era, what do we mean? What's compute, Martin? I mean, that's what computers do, is compute.
Okay, so that's a point of view. You know, if I...
No, in our point of view, that's actually true. No, so what do we mean? When HP talks about the compute era, what's it talking about?
Okay, so it's a differentiation between 30 years ago and where we're going to be in the future. So 30 years ago, compute was take a batch card, put it into a computer and look for some results from the program that you ran.
You were around at this time, yeah?
I certainly was. I remember batch cards very clearly. Oh. So that was compute.
Yeah.
You know, that, and the whole point was to do a job and get an answer. If you think about the compute era, the world has moved on dramatically. You could think about, if you think about all the smartphones collecting data, so rather than the batch card now, we're looking at collecting sensory information from all over the internet, feeding into something which is then going to be used to do some analysis on and get an answer. So that's what I would call a workload. So now what we're looking at is that compute as an environment, which is everything from the server to the storage, to the network, to the sensory, you know, feeding of information and the analytics that go on around it. So we're thinking about things as a compute world now, as opposed to a batch job, which was a discrete computer that gave a paper printout of the results.
I'm still not 100% sure why I get, you know, why that's a difference in what you do, and why it's a difference between what we're going to be doing next and what people are doing in the data centers now.
Okay, so I think it's the connection of everything. The connectivity from a smartphone device all the way through to the back-end data center. In years gone by, that was discrete blocks, and it was paper and paper in, paper out. The way that we move forward into the computer, we're now looking at the data center as the compute environment. So we're going beyond the server, we're going beyond the network and the storage, and we're now looking at data centers to deliver us the results as opposed to discrete components. So that's why we're talking about this as the compute era. It's about how do you deliver workloads from a data center to deliver results for the business as opposed to discrete components. Hence, not the server, but the compute from the data center.
So Malcolm, does this affect the way that Intel plans its products, develops the future?
For sure it does, yes. I mean, if you look at how things are headed to, in this kind of like down there, the way things are going is a lot of dynamic reallocation of workloads and being able to very seamlessly move workloads around between one device and the next. And it's all underlying, built on top of a virtualization platform. So we increasingly, down at the sort of building block layers, embed more capabilities into the hardware to improve its capabilities in a virtualized environment. We put more telemetry into the platform so that orchestration software up above can see what's going on and better decide how to automatically allocate the resources that it's got available to it. So although some of this stuff is in the making and it will sort of come to fruition as we go forward, the platforms today are beginning to introduce a bunch of new capabilities that can be utilized as we go forward.
Is this real, Lendo?
Yeah, a lot of it's real. As I said earlier on, I think sometimes the words can sort of get in the way. I mean, what I've done on this chart actually is, I think it helps if you break it down into some sort of specific things that are going on. So I think it's good looking back 25, 30 years, but actually, if we look at where people are today, a lot of the time they're still sort of working with a lot of fairly static application stacks, so dedicated hardware platforms to applications. It's the norm to have operational silos. So your storage guys, your networking guys, your server guys, your security guys.
We complain about that all the time these days, don't we?
Exactly, but you know that is the reality. And there's still a lot of manual processing, a lot of script-driven kind of activity in the average data center. And this whole cloud thing is something that, regardless of some of the sort of cynicism you hear around cloud, the Reg readers mostly tell us that they're doing something around cloud in one form or another, but at the moment it's mostly a bit ad hoc. So a lot of what we're talking about with this world of compute, this is sort of my interpretation of some of what HP is saying, is moving towards what Reg readers tell us when we say, what do you think the data center of the future is going to look like? And I have to say, not all Reg readers, because you know I've headed this chart here, the movers and the shakers. Whenever we run our surveys, you know, we always look for that group of people who are a little bit forward-thinking. You know, and those guys, they do their homework.
You generally find them on the register.
Yeah, absolutely. Yeah, they're there. About you know, 1 in 5 of our respondents usually give us some pretty good ideas on moving forward. So what do they tell us? They tell us it's about pooling resources. It's about a building block approach, you know, integrated stacks. It's about trying to break down some of these silos, whether it's processes, whether it's tools, just working across boundaries. They also, obviously, automation, particularly around workloads, is pretty important. And then what we're hearing, probably a smaller number, but the guys who are a little bit farther ahead in terms of thinking about how cloud fits into their future are telling us that they want a lot more sort of tight integration and coordination between what goes on in the data center and what goes on in the cloud. So that sort of more integrated hybrid approach is pretty important. And all of that is to drive what I've got on the right-hand side of this chart, a much more sort of dynamic service, sort of business-centric view of delivering IT. So a lot of what we're talking about with compute is really sort of anchored in that middle column on the chart there.
But it's a pretty big umbrella when we're talking about compute then, because it really sounds like it's just a way of thinking about absolutely everything.
It's a way of thinking about how you pull together a lot of disparate components into a coordinated whole that starts to behave a lot more like a single whole.
No, I
think
think
So the only thing I would add to that would be that if you look at, you know, we used to measure compute in MIPS.
Yes.
So, you know, and the MIPS trajectory has been pretty much linear for the entirety of my career. So yeah, we see, you know, how could you need that much more compute? How could you need that much more compute? And we just keep consuming it, you know, so, okay, fine. But when you look at this chart, the service-orientated level is not about how many MIPS you can deliver. It's going to be how many services that you can deliver. And there's a definite disparity beginning to appear between the linearity of the MIPS growth and the ability to deliver services. And it's all driven by this Internet of Things, you know, the usual buzzwords, and I won't trot out the marketing speak here. But the more you get into this interconnected world, the more the disparity between the compute power you have versus the amount of service requirements you have. And if you're going to address that, you have to completely go back and rethink how to deliver compute, as opposed to just getting faster and faster service.
There comes a point where you just can't run any faster to keep that. To keep your. Got a couple of questions. Doctor, I think it's our Dr. Stats. Let's put it in. But you might be. I mean, this is the wonder of the internet. On the internet, anyone can be Dr. Stats. How far ahead can IT pros reasonably expect to plan with any accuracy? Now that's important because we're talking about planning for 25 years ahead. And do we really have any idea what the next 25 years is going to be like?
So certainly within HP, we're working 10 years out.
Yeah.
And you know, one of the recent things which has just come out in the public domain is this thing called Memristor, which is a complete rethink about the way that we deliver. Well, it's not transistors anymore, it's a Memristor. It's a whole new category of stuff. And that's been in the making for 10 years. When we look at the compute architectures of the next 20 years, We have people that are working on that vision and that path right now, and we're beginning to talk quite openly about these things, and we'll come to that in a little bit further on in this Regcast. But we know what the vision is for the future. We are defining that, and I think in general the industry, that intellectual level, are pretty much in a broad agreement of the way that we're going to go. So I think the visionaries know where the end point is in 20 to 25 years' time. I think for the day-to-day pragmatists, you have to. So if I make the wrong decisions now, am I going to be diverted off of that path and have to come back again? So yes, it's really hard to plan, but I think if you listen to the visionaries and where we're going, even if only 50% of it is true, I think you can plan very much around that way forward.
There's wrong decisions that don't really matter.
Correct.
And there's wrong decisions that will box you in. Yeah. Mark, for the same, for Intel, how far ahead are you looking?
Well, Jim, I'm not sure we can get quite out into the 25-year time horizon.
They haven't, they're secret people.
I'm sure, yes, exactly. At least I'm sure somewhere in Intel that's happening. Just they just didn't tell me yet.
Down in the basement, that's where they are.
But I think one of the kind of fundamental principles has always been a bit in the Intel DNA. Said is drive what you're doing around the standards work sort of thing, because the more you kind of work within standards, the more you're going to get a wide ecosystem of players. You'll get more competition, more choice, and as this world develops, and honestly I think nobody knows exactly where we're going to be 20 years from now, but the steps that you take, if you take the steps that don't lock you into a corner so that you can adjust as we go forward, and the standards world is generally the best way to do that. So yeah.
I like your phrase, the Intel DNA, because I had no idea until now that Intel was designing DNA, but it makes
there you
perfect
go.
sense,
That's the next microprocessor.
It makes perfect sense. It's a question from Darren as well. Let's deal with that one early on, because I think it sets some stuff up nicely for the rest of the Regcast. He's saying that why do you think that automation and orchestration isn't being readily adopted yet, when the economics of a siloed infrastructure and manual intervention just don't make any sense? I mean, this is fundamental to what we're talking about, isn't it? That doing things manually in silos, it can't persist.
So I have a slightly, if I use an analogy, so when I started out of school, I worked for British Airways on autopilot systems for aircraft. So we're talking about 1974. We had autopilots that could take off a plane, fly it to Munich and land it, roll off the runway, fully automated. We're no further forward really on that now.
Really, actually, when you think about it,
than we were then. We use different logic to do it, different techniques. It's computerized as opposed to discrete logic. I think there is an adoption resistance. Are people really ready to move forward? Are they ready for this automated data center to run completely hands off? I am absolutely convinced it could. But there is a tacit inertia that you have to break through before people will say, I'm okay for that to run on its own. So at the moment, I think we're in monitoring, take action, and low levels of automation. But in the future, when you've got millions of processors and connected devices and stuff like that, you will not have the option to operate like that. So, we're on this trajectory to that world. We can do it now. I think there's an inertia to doing that. Dale, what do you think?
For complete automation, you're fighting against 50 years of really good science fiction films, aren't you? When it comes to things about the danger. Sorry, Dale, what were you going to say about it?
Well, it may not be obvious, but we have made progress. So if we go back to what we were hearing back from all of our research maybe 3-4 years ago, definitely, people didn't really trust automation that much. They felt it wasn't really ready, it wasn't really mature enough, they didn't understand enough about it, they didn't have enough experience. It's different today. There's generally a much, much higher trust and acceptance that automation is A, good thing, and B, actually you can do it now relatively safely. The problem is one of inertia, and just hours in the day, to be honest. And also there's another element which I pulled together those two questions actually, because we were talking earlier on about components and Intel making hardware more instrumented and manageable, and so you can actually sort of drive these things remotely. Well, a lot of older kit isn't particularly geared up to doing that, which does act as a bit of a blocker when you're looking at sort of.
So you want to automate things, it's got to have good information to act on, yes.
Exactly. So coming back to the how far ahead should you look, can you look? These are decisions that were taken maybe 3, 4, 5 years ago to put cheap and cheerful kit in place that wasn't particularly smart from an automation friendly, that are now sort of acting as a blocker. So coming up a level, I think that's a good lesson that now when we're looking forward over the next 7, 8 years, because a lot of the research we're doing at the moment it's telling us that people are looking at lifetimes of that kind of order, 7, 8 years for servers, storage devices, and so on.
That's an interesting, because we're going to get into the components of what goes into this, and there will be some things to do and not to do. Actually, we got one more question. It's Andy's question. I'm not going to give it to you now, but it's around how you build and the decisions he should be making around how we build for the future. So Andy, I'll hang on to your question. But if you've got any questions like that, then please let us know, and we will be putting them to the guys.
Maybe, Tim, I can just throw just a couple sort of off the cuff.
Yeah, sure.
I mentioned earlier on that Intel's a big consumer of all this new technology in our internal IT department. So, and a part of that is to enable and sort of share some best known methods and practices, and what's the pitfalls, how to go about it, and so on. So there is a lot of really useful information for people who are looking at all this stuff and thinking maybe, but it's a big jump. And so we do a lot of work in that area to kind of show how to roll out some of these things bit by bit to move from the old world to the new world. And I think since 2010, Intel IT have been utilising some of this new automated orchestration.
Yeah, I'd encourage people to go and check that stuff out. Intel IT is what it's branded as, is it?
Yes, yes.
And it's basically the Intel internal guys just making all their kind of learnings and best practice available.
This is what we did, because we had the stuff.
And there's a story goes back sort of 5, 6 years, isn't there? If I remember rightly. And there's an annual report, and then there's a whole bunch of stuff that comes.
It's not a sales pitch. It's very much technology sharing.
It's very real world. It's not esoteric.
Good tip.
Yep.
Let's have a look at some of that. Let's have a look at what the compute era means. Now, that's a definitive HP infographic there. So that's one of yours, Martin, isn't it? Tell us what's on this.
Okay, so if I can move beyond the compute definition, because I think we've got past that.
I think we've done that.
Yeah, I think we've done that. One of the things that we're really encouraging people to think about is move above the server. Think about the environment that you're trying to deliver business services from, whether it be cloud or whatever. So the past, siloed, manual, on-premise. The new world is the complete antithesis of that, or the opposite of that, which is everything together as a pool of stuff. So that's the converged infrastructure, so pooled server, storage, network. Even at the network, pooled integrated components like fiber channel and Ethernet, and bringing all of those things together so you can manage it en masse. So that's one element of it. Ultimately, what we're trying to do is get to a point where you can software define the data center, and everybody's got a slightly different term for this, so let's not get hung up on the term. But how can you reconfigure the data center resources through automation at a push of a button? So if you're going to do software-defined data center, you're going to think about, so what I need is, a web client. What I want to be able to do is go to a pool of server storage and networking, program it to deliver a certain sort of characteristics like how much memory and network connectivity and stuff like that, and then load the workload onto it and then deliver it out to whoever the users are. The next piece of that is the cloud services. Well, for me, cloud services are just a provisioning model. So pay as you consume and all the rest of it. Now, typically, if you're going to deliver really good cloud services, you better have a software-defined world alongside it. Because, if thousands of people want to run the next version of Angry Birds, like my sons would, you could just swamp the data center with requests for service. So you're going to have to be able to go, oh, somebody wants an Angry Birds image, it's off to this smartphone, whatever it be, iOS, Android or whatever. Push of a button, oh, well, we never touched that. There's another guy who's got an Angry Birds image on whatever their device is. So the new world, what we're delivering here is software-defined cloud delivery, whether it be on-premise or off-premise, all delivered off of a converged infrastructure underlayer. So you need these three things together working in tandem. So when we talk about the compute era, it really is this think how you provision in this fully automated way workloads, whether it be hyperscale, analytics, or whether it be web clients, whether it be hosted desktops, whether it be virtual desktop, whatever the workload of requirement is for your business, it can be all delivered off of this ecosystem, which we call the compute era.
That's because when we started out with this, and I didn't quite get it, I have to say, for quite a while actually. And then because I was asking you guys over the last few years, we've been talking about you got your data center. If you need more of anything, you just burst out to the cloud. That's what people have been telling us. And we have people in the studio telling us exactly that. And Del, I think as you pointed out, that's really asking the wrong question. That's not how you should be thinking about this.
Yeah, I mean, the two main things that I sort of chip in with, one of them is a phrase that we use, which isn't a very nice phrase, but it's kind of functional, is source agnostic. So when you have to power something, just think of the compute angle. I'm using the word compute now.
That's all right.
Where do those cycles come from? Do they come from this pool of resource internally in this data center, or your other data center at the other end of the country or in another country, or do they come from Amazon or HP or IBM or any other source of cloud services out there? So you should really try and get to a stage where it doesn't matter where it comes from. There might be considerations, and everyone will come back and say, yeah, but what about data, location and sovereignty and all this? That's fine, but from a technology perspective, it shouldn't really matter.
Yeah.
So I think that's quite an important
when if you need if you just need compute, it doesn't matter where that is. It's where the customer data is that sort of matters. So if you need to do a task, then really that doesn't matter at all, does it? I suppose in that case. But I do take your point. So it's when we're talking about this compute era, then it's got it's a very big umbrella that sits above even when we're talking about cloud and on-premise. It's something. You're thinking about it much bigger than that. Yeah.
And I think the other thing I would sort of add on to that is that as we get more automated, more converged, more software defined, the possibilities become ever more real. So the fact that you may have a toothbrush which is actually monitoring how many times you've brushed your teeth and all of this sort of stuff, and your doctor when you go to your dentist, he says you're not cleaning your teeth enough.
Your toothbrush told me.
Your toothbrush told me you're not cleaning your teeth enough, which is a really simple silly analogy, but actually is absolutely science fact, not fiction. It could be done now. The thing is, the more you do it, the more it grows, the more the cloud expands. And today, one of the factoids that got this week was that the public cloud today consumes more power than the whole of the Japanese infrastructure.
Hello.
That is massive.
Yes.
So if this gets massiver and bigger, pardon the English, then we just run out of power to continue this inexorable growth. And so the limiting factor is not just automation of workload, it's power as well.
Aha, so this is the thing. So we've implicitly assumed that the cloud is this infinite resource.
Yeah.
That we don't have to think about any kind of efficiency in marshalling our resources because it'll always be out there.
Yeah.
And what you're saying is basically we will come up against a constraint sooner or later on this. Sooner by the sound of it. If we're already consuming more than Japan.
Yeah.
Which is generally speaking a place that uses a lot of electricity.
That is scary.
As I recall. Okay, so that's an interesting point. Now, should we look at this in terms of more detailed products and things like this?
So when people talk to me, talk to customers about convergence, so what is the convergence thing? So things like blade systems. So this was the first converged system back in 2009. You know, and the whole premise of it was about sharing resources. So servers that were plugged into a shared network, shared power, shared cooling and things like that. And you would plug into it blades to do particular jobs they were tuned for, so like a virtualization blade or a high performance blade or a storage blade and all of those sorts of things. So back in 2009, this was a first step towards this sort of shared environment. When we move along, we then have things like the recently introduced Apollo systems, which is about doing massive hyperscale workloads, and in fact they're so powerful now we're having to water cool them, you know, but these are fundamentally using similar sorts of components as generic compute environments, but we're just building them out in a very specific way for a specific type of workload. The virtual connect, the ability for, you know, a server to talk to a server without ever going out to the network, or if it needs to go out to the network, it just pops out to the network and comes back again using a very flattened architecture. But it's part of, you know, the build. And then another example of the convergence is something called Moonshot. You know, very similar to Blade System. Blade System was a shared environment, first step towards convergence. Moonshot is another step along this convergence where, again, you have like a chassis to put compute nodes that are designed to do specific jobs. So a hosted desktop, it's as good as having a desktop on your desktop, but it's in the data center without all of the limitations of a virtual desktop environment through networks and all of those good things. So it's very specially tuned to do that type of job.
Right, and a question on this one, actually, and then I'm going to give you a couple of questions from here as well, so you don't go away with anything. So there's a question on this one. So the first thing that we said about all of this was it was just a common pool of stuff, I think was the technical term you used for it. So, you know, you've got a lot of things of everything and they're just allocated where they are. Now, when we're talking about converged infrastructure, and I remember when your colleague was sitting here, we were talking about specific boxes. There's a box that does this and a box that does that. So I'm going to ask both of you guys, how are these two things compatible? Because they're not.
Okay, so if I take the Moonshot world, okay, think of the chassis as a container that you can put different workload cartridges into.
You can design it for different things.
You can use different things in the same chassis. So rather than having a chassis which is a VDI chassis and another one which is a Unix stack and whatever, this particular chassis is built as a shared all type of environment, and these cartridges go in as self-contained servers. So you could have a rack of Moonshot chassis that had 1,000 web clients in it. And you could carve up these servers at will with the software to do like groups of work.
But it's still doing web client.
But it's doing web clients. But you could actually take all of those out and put a bunch of hosted desktops in, and it would become a hosted desktop environment.
That would be, yeah.
You could actually have a Moonshot chassis with a bunch of web clients in, and underneath it one with a bunch of hosted desktops in it, and another one which is the analytical box. And you can actually manage these as pools of compute. Okay, but it just so happens that chassis is the web client one, this is the hosted desktop, and this is the analytics one. And you can carve it up into elements, which is a clue to what the future of compute looks 20 years out.
It's like a halfway point.
It's a halfway point. Yeah. So Blade System was a start point. Moonshot is another workload optimized point, and in the future we're going to go out to something which looks radically different, but you will see the management, the shared network, the shared storage environments, you will see that DNA in the future as you look back. So these are all stepping stones to what the future looks like.
I think I get it. Malcolm, is that how Intel sees it?
Maybe we're slightly, we're close, not exactly 100% in line. I think
this is what I like. Come on.
So I kind of think we see a sort of a data center of the future as we go forward. A lot of standard compute, storage, networking capabilities that can be dynamically reallocated. Whatever the orchestration software sees a need, it can put tasks and loads out onto those dynamic reconfigurable units. And I think the two-socket platform is fast becoming the base building block as the standard unit. And then, as Martin's been talking, there'll be sort of workload optimized bits and pieces around that the software sitting up above can say, if I've got a workload that particularly requires some special capabilities to do this, then I'll put that one over here on this thing, because that's really architected for that job and will do a great job. So it'll be sort of bits around in that sort of thing, but this big mass of sort of general purpose building blocks underneath that can be reallocated as you see fit.
Great. Now let's go put Andy's question, because he's been patient. I hope you're still there, Andy. And no, but he's a serious one. It's about what he's building now, and he's talking in these terms about it. And he's saying, if they're building on commodity hardware in a compute model, will HP be providing a sort of software defined SAN? I mean, I guess we come into it now. We're talking about the storage and how that works in it, because we're talking a lot about memory and processing and things like that. Storage is a little bit difficult to involve in this world, isn't it?
Should I take that one?
Yeah.
Yeah, let me take that one.
Hey, I was looking at you like you
Okay,
I'm not going there.
Software-defined storage. I mean, we're already at a point where we deliver software-defined storage. So the same array fundamentally can have different spinny disks in it, different tiers, where the whole thing can be reprogrammed to put storage, store your data at the right tier of storage. Mm-hmm. You can do that right now.
Yeah.
So if you've got solid state disks, you could have a complete solid state disk array. We're at that point, so the economics have now moved beyond should I or shouldn't I. It's a case of if this data requires that level of performance, it's a no-brainer, whereas it could have been cost prohibitive in the past. So we can do software-defined tiering of where we store the data into solid state, high speed, low capacity, low speed, high capacity, and fundamentally you can put it to the right cost of storage tier. If you think to the future, maybe you don't have spinning disks anymore at all. If you think about the future where memory, everything is memory resident, and we'll explain a little bit more about that later. If you can think about that, where actually that becomes a non-discussion anymore. It's where is the data stored, and is it universally available to all of the servers and the connections? So right now we can do software defined. The storage in the future could look radically different than what it looks like today.
People will say, do you remember when we had discs and we used to discuss what kind of discs that you bought?
Yeah,
that would be the thing.
I think the short answer to those is yes, isn't it?
Yeah, the answer is
HP
yes.
can
Basically, yes
The answer is
now.
yes. What's the question?
Yes now, future. You might not want to. You might not want to have that anymore.
Yeah,
but that's a far future though. That's not
Absolutely.
next year.
Basically, I mean, software-defined storage is a bit of a sort of amorphous topic. There's one form which is basically taking the stuff that you'd normally have embedded in an array, pulling it out and having it in the software tier, and then there's very sort of esoteric specialist stuff, Swift in the open. That's how esoteric. I mean, this is all real-world stuff, and obviously it's being used for real heavy processing in certain service providers and Ceph, and there's a whole sort of world of newly defined, completely different ways of managing storage and data.
And I think the most important thing, as you said, the new ways of managing it. The one thing you don't want to do is to get physically involved in the tiering of where the storage is. What you want to be able to do with confidence, back to our previous point about, do people trust this stuff? Is trust it to put the storage to where you want it to be based upon the policies that you set.
This is a very good example of exactly what you were saying, a very practical example now, where you're working now to a future, an automated future, which has advantages.
And I don't know the details of the HP storage solutions in this space, but most of the software-defined storage solutions will actually allow you to stitch in existing arrays, so you can actually sort of reuse your existing kit and get it part of the same software-defined environment. So you're not having to sort of throw stuff out. Keep
asking the questions, guys. These are very good ones. Can I ask you one from Jonathan Pelham? This might I'm going to have to ask you to answer this in just a couple of minutes so that we don't run out of time. Will we see companies delivering cloud services as a platform for experts to create knowledge-based engineering tools? I don't even know what those are. Oh. And it's like splitting the infrastructure providers from the model writers.
Gosh.
Should we pass that one on to your colleagues and get them an answer?
Good idea.
Yeah. So I thought the fact that I didn't understand it wasn't indicative of anything.
I'm not sure I understand.
Let's move on.
Yeah.
Next slide. So you'll get an answer for it, Jonathan.
Yeah.
You will get an answer
come
for
back
it.
to
We
that
always get you an answer, but we're going to find someone else to give you an answer, and that's going to be the best thing for us. Now, so looking at the server industry and how it's going to change based on that, and then we're looking, very much on the sorts of things that people might start thinking about now when they're thinking about making their plans.
Mm-hmm.
Yeah.
So this is coming at the same problem from a slightly different angle. So across the bottom there is the demands, ever more data, ever more complex. We were talking about where is stuff stored. That actually becomes more and more complex the bigger the data sets you're trying to deal with and the bigger the enterprise you're trying to deal with. So, key things about how do you simplify, so therefore how do you automate, how do you drive down power. If I just think, as a really good example, HP runs its entire web client environment on Moonshot now, and we save millions of dollars in time and power in terms of running it off of a Moonshot environment, because we use low power, very, very simple processes in that type of environment. So how do you deal with efficiency of people, time, resources, and power? And then last but not, the agility thing, it comes back to the automation. If you want to move workloads around, you're going to have the ability. Actually, it's just a pool of stuff out there. So how can I move this analytic workload from this data center to another one at a push of a button? So that's the sort of world that we're trying to deal with. So what people really worry about is the workload optimization of it. So as you sort of run around to the right-hand side, anti-clockwise here, the workloads. Is it analytic? Is it hosted? So there's many, many examples of workloads. So how do you create dynamic workload optimized environments as opposed to static, siloed, and all of that sort of stuff? So when you look at the things that we're doing is that, the advancing technologies. So we talked a little bit about Moonshot. In-memory computing is a big thing right now. Yeah. And I've been working on in-memory computing probably for 20 years. It's now at the point where it's economically viable to be done on a commercial basis as opposed to, science environments. So in-memory computing becomes more and more of a problem in terms of how do you do it at scale. So therefore all sorts of technologies, the memristor is part of this sort of in-memory in-memory computing environment we're thinking about for the future. Power and cooling, sensed, dynamic, turn things on, turn things off, that fan's not required, turn the fan off, all of those sorts of things. So all the things we've been doing with Intel in terms of sensory stuff absolutely is fundamental to the power and cooling. How do I turn the data center cooling down if I don't need it? Because actually it's consuming more power cooling than it is running the data center. So we're doing some really clever things around there. The photonics, moving stuff around at the speed of light, critical for the future, because the one thing which slows things down is copper. So, the things that we're doing around photonic light transfer is really important. The memristor we talked about, management, absolutely key to what the future is. So that the one view thing, this single pane of glass management of infrastructure, where you can do it through your smartphone, that is the way forward, not the way backwards. So these are all the things going forward, and all of that is actually to support self-service or traditional delivery models, because ultimately you can't just ask people to throw all their old stuff away. What we have to do is take this stuff with us to the future, whether it be Unix stacks on discrete platforms or whether it be a Moonshot environment going forward. We have to take that all forward.
Malcolm, does this mean that you end up having to work more closely with people like HP because you're producing a lot of the information that's you're building in the sensors for a lot of the information that they're going to need to be able to make this work?
Sure, actually, I think the work that's going on at an engineering level between Intel and HP and a lot of the software community that's out there is getting ever more sort of deep, because as Martin was saying, there's more and more telemetry inside the platform. There's more and more fine-grained control. Do I want to turn on this core? Do I want to turn down this core because I don't need him right now? Am I going to move this workload from here over to here? And all of that sort of automated control means a lot more cooperation that's going on amongst the players, and a lot more reliance on everybody running on the same standards to achieve that.
Now, talking about reliance, got a question in from Lord Vetinari.
Wow.
Okay.
Yeah, I wonder if he's a real lord. And he's saying it's about storage, but it's something quite similar to this. He's saying trust in storage is very hard earned. Protecting data for long lifetimes is difficult. A software-defined fine storage systems he's talking about now, but it's a general pointer you can make as well. Is this ready for mission-critical systems? When is it ready for mission? When can we have the confidence that this sort of doing this, trusting the machine to do it for you, will create something that A, doesn't get you into trouble, and B, is as resilient, more resilient than we've got now?
Well, the short answer is it's ready now, and it's being used in some pretty humongous kind of service provider environments. And a lot of these software-defined storage environments, when you get on beyond simply replicating an array in software, and you get more into sort of distributed storage, by definition, you send something to that beast, and it's a huge cluster. Or it can actually be quite a small cluster, to be perfectly honest.
Yeah.
It'll automatically make multiple copies for you and distribute them in the right kind of way to give you inherent resilience. So actually, you don't have to worry about a lot of the things you would normally have to.
Because it's actually doing the thing.
It's introducing redundancy on an ongoing basis.
This safety behaviour is also, you can also automate that.
There are some, the areas where developments, particularly in sort of the open source projects are going on quite rapidly at the moment, is getting that working between sites so that you've got sort of between site redundancy and so on. So some flavours work, some are still work in progress. But actually, inherently, this stuff is pretty rock solid.
Let's move us on. So we've got just a couple of things talking about converged infrastructure now. As converged infrastructure is kind of the future today. Mm-hmm. It's basically what you're considering to be the future, and what you can buy as a thing today is kind of like that, and that's that's on the path.
Actually, the availability thing sort of is part of that. I mean, these things, because you've got inherent sharing and redundancy in these kind of environments, availability tends to come almost as part of the deal. Mm-hmm. So you don't have to spend as much time necessarily engineering, failover, and you still need to think about DR, obviously, in the event of an ultimate disaster. But you do get a lot of benefits in terms of availability, just inherently in this approach. Yeah. In terms of standing stuff up, the whole point of this is rapid provisioning in many respects.
Yeah.
And when we go and talk to, as Reg readers say quite often, the higher ups, the guys who sort of control the budgets and run the business, most of the time, if you ask them what's important to them, they want to get IT off the critical path to doing stuff within the business. So basically, when they stick in a request for a new system or even a change to an existing system, they want it done like that. And how far you can do that, because there's lots of dependencies in larger environments, is questionable. But certainly, what we want to do is get the operations piece off the critical path, and that's a lot of what this is about here. And in doing that, because you're just getting rid of a lot of overhead, because you're automating and streamlining, your operational costs go down. So that's what this graph's about. It's my interpretation. This is an HP chart, but it's. Did
he get it right, Martin?
Yeah, no, he did actually. No, he passed. Because I think the availability is, a lot of people in the past, it was availability was the fact you got two of everything. Yeah. Now it's not two of everything. There's a mesh of everything. Yeah. Mm-hmm. And part of that mesh could be the cloud. Mm-hmm. So if I've got something, my data center looks like I'm running out of capacity, then actually I can just burst out to the cloud, but I automate that, which means instead of a week to get the cloud up and running, at a push of a button, I have this burst capability, so the operation of that cloud is within minutes. Or if I want a new application stood up, I can do it in minutes. I think the other thing is, so it's not always at that level, just something as simple as, and the availability and operations thing comes together now. Doing a firmware update, I suspect, is the bane of everybody's life. They treat it with trepidation, because when I do this firmware update, is it unpredictable what the result of it's going to be? So number one is it's probably nice to have modelled it first. So yeah, let's have some modelling software that checks it out first. But also the ability to go push button across an array of servers is not only does it keep your operation up and running, but it also means it's done in minutes, not a week's worth of planning and days of downtime, but also it means everything was kept running as it was going. And we're building that into our capabilities.
So that's an example of bringing all this kind of pretty theoretical stuff into the real world.
Yeah.
And I think another thing I'd do to ground this is say a lot of people talk about bursty workloads, and actually bursty workloads as of today are pretty rare in IT. They exist in certain types of businesses, but largely speaking you're not talking about minute by minute, even hour by hour dynamic changing of requirements. You're talking about day to day, week to week, maybe even month to month. But even so, it's coming down from we could stick that system in and leave it for a few years to now it's probably only going to be a few months in some systems as we get more sort of outward facing systems. A lot of even relatively small companies now are getting into more externally facing systems as the world goes digital. The way they interact with their customers and people in the field.
So we've been talking for the last few years very much about the sort of workloads that go like this all the time. This isn't it. You're saying it's a pressure building.
It is, and those timescales are getting shorter. But as of today, and probably for the next 3 years or so, we're more talking about week to week, month to month fluctuations. But those are still really disruptive and really time consuming to actually deal with as the business changes. But it will speed up over time, and those bursty workloads will become more common over time.
We've got about 10 minutes left, and I just want to very quickly just have a look. This is some things, and actually if people want to look at this longer, they can get hold of the slides for us. But you should very quickly, Martin, just run us through this one in 30 seconds about these are some of the benefits we're getting in converged infrastructure. Yeah.
Okay, so I think most we think about servers and we think about all of the component parts, but actually from a business point of view, how can I analyse this massive data my company is producing? And actually, it doesn't matter if it's a small company or a big company, we're all creating a lot of video, a lot of textual, a lot of record-based stuff. So if I could tap into that without a major scientific project, how useful would be? So, we've got some really good examples of Twitter data. I'm a Twitter user, even at my age. Everybody is going down this path, regardless of what our age is. If I could tap into that Twitter data as a company, just think what that could mean to the business, whether you be a small or a big business. The growth thing. A small business today, who knows this exponential curve you could get on if you tapped into this Twitter type of environment. Who knows where that could be? Do you really want to be limited by what you've got in terms of your infrastructure and your compute strategy? So, we've got some really good examples here of a service provider went from very small to very big, because this is obviously a massive trend at the moment. They were able to do that, otherwise they could have been constrained. And I think, the last one is, how can you change to respond to the changing shape of your business? An example of a logistics company here that was able to look at the services they offered, was able to stand up the application environment to deliver that in very short space of time. And they basically just reconfigured their infrastructure environment, their converged environment, at a push of a button, probably stretching a little bit, but not a major 2-year project, something that was planned and executed in very short space of time. So what we're seeing is the business benefit from this, not just an operational benefit.
I'm going to make 2 points on this. One of them is this kind of implies, if you read it in one way, that you've got a choice about getting into things that are going to stress your infrastructure more. We've got some examples in a minute that we'll come on to. Most organisations are not going to have a choice. Their infrastructure is going to get stressed by things just naturally coming into the organisation through the back door. I think the other big point is that a lot of this stuff is something which you got to be careful of thinking about it as an all or nothing. So if you think about your entire business, your application portfolio, you've got some really, really fast moving stuff at one end of the spectrum, and you've got some really sort of static stuff at the other end.
Yeah.
So this stuff is almost, you might get around to actually applying some of these principles at this end at some point, but actually be selective about where you start with all this stuff. You don't have to do everything at once, but there are certain classes of application that will almost mandate these new approaches before too long.
So spot them early,
yeah,
and then you'll get a benefit from it.
We'll come on to some in a minute and we'll give some
There we
examples.
go. So let's have a look at this. We've got about sort of 7 or 8 minutes to go. So let's give some advice to people about what they should be doing now, so they can get to this future.
40,000 feet level, let me just put this into context.
Yeah.
If you're building a strategy and roadmap, there's no rocket science behind this.
No.
One of the things you can do, it's like the old channel tunnel thing. You start digging it from both ends. Ideally, you want it to meet in the middle. It's the same with kind of roadmaps and strategy and planning. You take your vision and you work backwards from that and say, what do I need to do now if I'm heading towards that kind of vision? But at the same time, you start this end and you say, but there's a whole bunch of stuff on my to-do list, and I need to, buy some new kit. I need to do some development work. I need to do whatever, and that's very tactical. And if you get those two joined up, then you can use both those requirements as inputs into building a sensible strategy and plan. Vision.
Okay, so this is fascinating. There's a lot of stuff in the public domain at the moment about what we think the compute world of 20 years out from here looks like, and we've specifically not called it the server or the compute world. We've actually called this thing the machine, because it is such a radical change from the way we look at infrastructure today. So when you look at this thing called the machine, it is a whole bunch of compute cores. And these compute cores could be. This is
kind of like your vision of the thing, Malcolm, isn't it? Yeah, the machine is. It is. It's yeah.
Yeah. So it's these compute cores, and you may have low power cores. You may have very high power cores, but fundamentally these are compute cores. They're just universally available compute cores, standard commodity stuff, connected to through light transfer, whether it be on the compute boards. I mean, I'm using an old analogy here because, will there be boards in the future? But, within the chip, outside the chip, into the data center, across the world, using photonics. That's the big picture point of view. Everything connected by light, because copper constrains. Yeah. To a storage which is actually not necessarily spinning disks anymore, but is just a universally available pool of memory. So this mesh of stuff, and it could be spread across the world, got a data center over here, got a data center over here, actually up in the plane, in your phone, this mesh of compute, the machine, would actually be able to operate at scale that we just got no idea of being able to do today. And the real practical examples of this would be, you think again back to my heritage of planes. The plane flying from London to New York, today, if you could capture the sensory data on it, would probably generate about a petabyte's worth of data during that flight. If you could connect that to this machine around the world, where you could then share that stuff with all the other planes that are flying around and meld all of that stuff together, you could divert the plane around bad weather from the ground. You could save fuel. You could look at people's video consumption patterns on the plane. You could look at what duty-free goods, if there is such a thing in this new world, duty-free goods that they're buying. So out of that data, you could share with all of the commercial environments at scale what you could do for not one aircraft but your whole fleet. Now that level of analytics requires this machine type of approach of universally available storage connected by light to this pool of cores that you can carve up at will to do specific jobs. That's what the future looks like 20 years out.
You're going to have to think of a nicer name for it than the
absolutely.
machine, because that's going to scare people to death.
Yeah.
We've literally got about 2 minutes left now. So what we have to just look at this. I want you to pick something, just one or two things from this, just in a couple of minutes we've got available, just to be able to tell people how they should be behaving. Dale, first of all, you.
Right, so what all this list has in common is this is stuff that a lot of people have on their to-do list already.
Yes.
These are fairly innocuous things. The next version of your ERP system, CRM system, the upgrade to your Exchange server. All these things, whether you decide to bring them in or not, will come in with a whole bunch of new capability, whether it's handling new data types, whether it's working on stuff off live data as opposed to stage data. There's so many things that will just come in through the back door in terms of increased capability, and we know that users and business people in general will take advantage of them. That will stress your infrastructure without you even electing to go and analyse Twitter
without
feeds.
thinking about the future.
Yeah.
Malcolm, very quickly.
Very quickly, I guess I would say that the challenges that you're trying to solve in the short term, those of efficiency and agility and lack of resources and so on, make the right decisions now. You can also lay the foundations for where you're going to in this great vision of the future. Not to harp the point, but the world of open standards, choice, a wide broad ecosystem is the route to take to head down that road.
Yeah, Malcolm, you got one sentence, literally.
One sentence.
Yes.
Right. Get somebody who does this stuff for a living to help you build your roadmap. So, back to your point, pick the workloads.
Good one. Thank you very much. We're out of time. Thank you very much, guys. Hope you've enjoyed it. I'm Tim Phillips. Goodbye.